This is a video about logarithms and specifically what is a logarithm. The short answer is that logarithms are the inverse of indices or powers. So I don't think you'll be surprised by the fact that 10 squared is 100 and 10 cubed is 1,000 and 10 to the 4 is 10,000. What logarithms are a thing that allows us to rewrite this relationship as log to the base 10 of 100 equals 2 and log to the base 10 of 1,000 equals 3. And lastly, log to the base 10 of 10,000 equals 4. Each one of these pairs of statements are saying the same thing in exactly the same way as 2 times 6 equals 12 is saying exactly the same thing as 2 equals 12 divided by 6. The number relationships that are being described by these two sentences is the same. The same relationship is being described in two different ways. Logarithms are just a different way to describe this powers relationship. So, what that means is that asking what is log to the base 2 of 15 is the same as asking 2 to the power of what equals 15. Well, these are two different but equivalent questions. And I think it probably wouldn't surprise you to know that this is about 3.91 because 2 to the 4 is 16, so it's a bit less than that. In the same way that you could look at these sorts of numbers and say, well, log to the base 10 of 500 must be somewhere between 2 and 3. And log to the base 10 of 8,000 must be somewhere between 3 and 4. Why is this useful? Well, if I just continue this on for a minute, 10 to the 5 is 100,000 and 10 to the 6 is 1,000,000. 2, 3, 4, 5, 6. So log to the base 10 of 100,000 is 5 and log to the base 10 of 1,000,000 is 6. Suppose you're dealing with an experiment in which the ranges of the data can go from 100 to 1,000,000. If you're trying to plot that on a graph, trying to plot that on some axis, you couldn't display everything in a sensible way. But if you take the logs of all of your data, you get to running between 2 to 6. So while these values have run from 100 to 1,000,000, these values have only run from 2 to 6. And that means I can actually display this information in a useful way. It gives me something that I can get hold of and play with in the same way. Whereas start playing with numbers of 100 and 1,000,000 in the same sentence is a very, very difficult thing to do. We have two very common log bases. The two most common log bases are log, which we use to represent log to the base 10, and ln, which is log to the base e. And e is Euler's magic number, which is 2.718. I can never remember it in the right order. 2818 and so on. Euler's number is a magic number. You should look it up, Google it. It's a really interesting number. How do we actually find logarithmic values? Well, what we usually do is to use a change of base law. So we use this brilliant little piece of magic that says log to the base a of b, whatever a and b are, is equal to log to the base c of b divided by log to the base c of a. For any a, b and c, this works whatever a, b and c are, this always works. In practice, we typically would just use the natural logarithm. So we would say this is the natural log of b over the natural log of a. So if we were to do an example, we might say, what's log to the base 4 of 19? And you would hope to see quite quickly that log to the base 4 of 19 is a little bit more than 2, because 4 squared is 16 and 4 cubed is 64, so 19 sitting somewhere between 4 squared and 4 cubed, so it's going to be a bit more than 2. What we would do is take log of 19, we would divide it by log of 4, and our calculator would tell us that log of 19 divided by log of 4 is 2.12. So there you go, that's what logarithms are, and how to use a change of base to find simple little logarithms.